Good afternoon. My name is Brant Mackey, and I will be presenting the AttackIQ platform demo today. I think we'll give everyone probably 2 more minutes to join the webinar until I get things started. All right, welcome everyone. Once again, my name is Brant Mackey. I am the VP of Field Engineering here at AttackIQ, and I will be presenting this demonstration of the AttackIQ platform today. You can see that the title of my slide is Continuous Security Validation. We are AttackIQ, probably more often known as a BAS platform, breach and attack simulation. When we started the company and it was founded, there wasn't a market called BAS. We appreciate Gartner creating that market, giving it a label, and we do consider ourselves a BAS platform because of that. But if we were given the opportunity to rename that market and what we are trying to accomplish, then the title would be Security Controls Validation. And that's just me, in my opinion. BAS is one method of accomplishing that kind of testing, so emulating adversarial behavior. But ultimately, there's a broader capability that we've identified that we want to be a part of. Today, I'm going to walk you through the platform, show you some of the basic workflows to execute a security controls validation program or a BAS capability. But before I do that, I did want to have 2 slides here to lay a little bit of groundwork and provide some context before we jump into the platform. The first one is just speaking to the origins of AttackIQ. So we've been in this industry for a long time, selling, implementing security technology. And so we understand that one of the gaps that's been there for a while is really understanding the efficacy of those security products. You purchase them, deploy them, they get patched, they get updated, they get reconfigured by humans on a regular basis. At any point in time, can you point at that stack and answer the question of how effective is it today at doing what you deployed it and what you expect it to do? There's value in having that answer, and thus the birth of this AttackIQ platform. We want to answer that question, and we want to help customers answer that question about their production environment and the security controls that are protecting that production environment. So how effective are they in the context of production? Let's exercise those features and capabilities of those security tools to make sure they are active and effective. That is the security controls validation piece. We can layer on top of that, and that's where the BAS comes in. So breach and attack simulation, let's look at the tactics, techniques of the adversary. What are the bad guys doing? So if you are familiar with AttackIQ and have sat through some of the academy classes, you're probably familiar with the concept of a threat-informed defense. So it's not just about obtaining and deploying all of the latest security tool sets. It's really deploying them in the context of what you're trying to defend against. So understanding the adversaries that may be targeting you in your industry, and building your defensive posture specifically around that threat. And then measuring how effective that security posture and those security tools are with that context. So let's select adversaries that we know to be potential targets or attackers of our environment, and let's test ourselves against their tactics. That's where BAS comes in, and we will be demonstrating both kind of workflows today in the platform. So one other thing that I'm going to do, I am not running this as a webinar where everybody's muted. I know we have several people on here, but when I run demos, I actually like to be interactive. So if you want to come off mute and ask a question or dig deeper into some aspect of the platform, I'm happy to field those questions live. So just be aware that I've lifted that restriction, so you can come off mute and be vocal. All right, one last slide before we jump into the demo. This is the architecture slide. This is the basics of this AttackIQ platform. And we are going to start with that top right object. That is the web UI that we will be jumping into shortly. This management platform is offered as a SaaS service. We are hosting it in the cloud. We create tenancies for customers. We provide links. Customers log in, activate their tenancy, and then start their workflow. Typically, that workflow runs through the web UI. But there's also a REST API as well. So there's a programmatic interface to manage this platform and all of the workflows and extract the data and results if you wish. That basic workflow typically starts by deploying a capability to conduct testing. So we are running through workflows, maybe adversarial emulations or simulations, or just test triggers. We need a launch point for those, and thus we can call them agents, but they're very lightweight software presence that is designed to deploy out to existing production systems in that environment. Windows, Linux, Mac, all of those can host this agent. Once that agent has been deployed, those agents check in to the management platform, report themselves as active and available to conduct work, and then sleep with a periodic check-in until they've been assigned work. That is the launch point of the different workflows that we will be running today. The next piece to talk about is that top left object. So we will get into exactly what kind of testing we conduct through these agents, but the scenarios that we call them, the tests that we run, have some kind of objective. And so it may be creating persistence. If you're familiar with MITRE ATT&CK and that framework, we align very closely to it. So you'll hear me use attack references in regards to the tactics, techniques, and procedures that they've documented. And I'll showcase how we do a lot of visualization and alignment in the platform. But as an example, using a persistence tactic, maybe I'm trying to create persistence by modifying a registry key. This agent that runs on Windows will perform that action, and then we'll validate whether or not he was able to establish that modification and establish persistence. At the end of that scenario, he will clean up, revert any changes that were made, close out the scenario, and move on. So initially, we're testing for some kind of prevention or interdiction capability. We want a security control to recognize what we're doing and stop us. Thus, all the scenarios do that. Secondarily, we know that not all security controls are designed to block or interdict. And so there's a lot of tools that are in the environment just monitoring, maybe workflows, configurations, network traffic, and they're either interdicting or creating alerts on their dashboard based on what they see. As a platform, we want to test those types of security controls as well. And that's where this integration manager comes into play. As we're running these different workflows or scenarios in that environment, we are tapping into those security consoles. We are looking at that alert feed so that we can see if a technology did recognize the behavior that we just initiated, and did it create an alert in its dashboard so that we can give it attribution. So our final report card when we're running these scenarios is first a prevention outcome, but then secondarily a detection outcome. Was there an alert? So today we are going to dig a little bit deeper into that integration manager. Today the theme is Splunk, and Splunk being one of the technologies that we can tap into using the Splunk API. And so we'll talk about running various workflows where we are looking at the console or the alert feed of the individual security technology. Maybe it's an EDR, maybe it's Palo Alto, a firewall. And then we'll look at Splunk, make sure that the alert was seen in the unique technology, but also that alert made it up into the SIEM. And then we can look one layer higher. So maybe you've set up correlation rules or alert triggers in your SIEM as far as Splunk. And now we can run the workflow, make sure that the individual security technology did create an alert. It did feed that alert up into the SIEM, and the SIEM fired off its correlation alert as well. So basically running full stack in the security pipeline to validate that the different components are responding appropriately when there is some kind of workflow or trigger that occurs. All right, before I jump into the demo, any questions about the architecture or what I just described here? All right. In that case, let me make sure that I can, that you can unmute yourselves. So just confirm that there was a comment or a question. So please do try. If you can't, if you can type out a question, then hopefully I can see it and answer it. All right. What you are looking at now is the AttackIQ management platform. And I'm going to start here in our demo lab environment. And so we have obviously the management platform. The first stop that I'm going to go into in the demo is our agent management location. So this is where I get the agent package that deploys out onto the different systems in the production environment. Windows, Linux, Mac. You can see the various flavors here, but here's the Windows package. So this package is very lightweight, designed to run on everything from Windows 7 up to the current release, both desktop and server, 32 or 64-bit. Single package just speaks to how lightweight that footprint is. Same thing with Linux, Mac. Once I have agents deployed out in the environment and checking in, then I can manage my inventory. I have a list of what agents are there. I can associate them with detected technologies. I know if a system has CrowdStrike versus Carbon Black, and so I can organize my different agents in that manner, or several other criteria. A lot of ways to create grouping or structure around the agents themselves. Probably more important, more fun, once I have agents deployed and checking in, I can start to assign them work. And so I'm going to jump into an assessment that's already been created and has been running pretty much on a daily basis for a while, and talk about what the structure of this assessment is. So the first stop in this assessment is the basic setup. So in setup, there are two main configuration options. Number one, I need somebody to do this work. And so here I have the ability to assign assets or agents specifically to this assessment. These agents will be conducting the workflows involved. I can assign individual agents or the dynamic groups of agents, a lot of ways to organize and execute the work. The second configuration option, what is the work? What kind of testing am I trying to accomplish today? This assessment is structured in the context of different security controls that are commonly in an environment. So you can see I have a test group that's focused on endpoint protection, or EDR. I can see that there are 7 scenarios in that group. I can open up that group and get an idea of what kind of testing is included here. So based on this sampling, you can see that I will be doing some credential harvesting, some discovery, some recon, maybe setting persistence using sticky keys, some execution methods, the app init DLL script, and so just a handful of different test cases, or TTPs, that I will be executing, all specifically designed to measure some kind of response by a security control in the environment. So is a security tool going to recognize this workflow that I'm running, and how is it going to respond? Is it going to stop me and prevent the completion of one of these scenarios, which is good. We will report on that. But secondarily, did an alert pop in that dashboard? And then we can make sure that that alert that may have popped in the EDR dashboard actually made it up into Splunk or the SIEM. And then lastly, if we had a correlation rule that is looking specifically for this type of activity, did that correlation rule fire as well? And so I can go technology by technology and look at the different types of testing that are being conducted. And so we can get into this deeper, or we can schedule time to explore this a little bit further. But for the sake of time today, I am just going to go to a previous run of this. You'll notice that I have green lights across the board. So there are configuration options with scenarios. In this case, all of these scenarios have an appropriate configuration and are ready to run. And so there's 2 methods of actually executing this assessment. Number 1 is the on-demand, or the manual execution. So here I can see that I have one that's in progress. I started this earlier, and I can see where it is. It's actually going through and collecting that detection data from those technologies where it's connected to. And so pretty soon I will have data populated there. The next option is scheduling. So once I have a baseline and understand how my assessment runs, then I can manage the schedule. And I can see that in this case, this assessment runs daily at 8:30 a.m. UTC time. If I want to modify that, I can adjust. So I can change it to a weekly, monthly, yearly, or some kind of hourly interval if I wish. And here's where I can also associate reporting to the execution. So I can email, in this case, a summary report or a detailed report to myself whenever this assessment completes. So I have a record of what's going on with this assessment. So once the assessment runs, then you have results. And results come from a lot of different methods. In this case, it's still running, so I'm going to bounce to the last run that completed. So you see the 2 main result criteria. The first one being prevention. Did some kind of security control prevent me from accomplishing each scenario? And secondarily, we have detection. So we ran the workflow, we checked the different consoles of the security tools looking for alerts that matched our behavior. And then we have the overall combined. So between either a prevention or a detection, out of all the activity that I executed, 62% had some kind of response from a security control. I can scroll down into the structure, in this case, structured by the type of technology, and get more detailed data sets. But from here, I'm going to drill down one more layer into what's called the summary view. So this is a list of every scenario that ran on every one of those agents that was assigned here, with first a prevention status and then a detection status. So you have the historical result summary as well. So how am I doing over time, both from a combined outcome versus the detection and prevention. If I want to drill down deeper, I can take it one more level down. So here is a scenario, dumping SAM using volume shadow copy. If I'm not familiar with this technique, then I can click on the question mark where we describe exactly what this scenario does, how it functions, what it is, how we've implemented it, and why it's important to you. We actually take it one step further and provide access to the source code. So there's over 2,000 scenarios in this platform and library today. We provide source code to all of them, to our customers. So we want our customers to understand how we're testing their security controls and how we're executing these workflows in their environment. This is good for visibility and communication. They can break open these Python packages and see exactly how the adversary functions or how we're testing their security control. Or they can make modifications. So if they've implemented either a unique security control or a security control that runs a certain way, they can change how these scenarios execute. And there's multiple ways to do that. There's variables in the web interface to do that. Or they can modify the underlying Python package and create custom content themselves. The platform supports and actually encourages the modification in that use case. But here we actually have the results of the attack. So digging down into the details, what's important is that we have very detailed step-by-step logging as that scenario executes. You'll see how we ran PowerShell that invoked volume shadow copy. It ran successfully. We did our file extraction and then cleaned up our mess. We have mitigation recommendations at each phase. So you can see we start fairly generic, but then get into some specific changes that could be made that could prevent this phase of an attack from being successful, along with further reading. And then detection details. So in this case, I have a detection. So I can see where I had a match. CrowdStrike did feed up into Splunk, and I was able to find that alert here. And so we're going to get into that in another view and talk about the correlation matches as well shortly. But any questions about that basic workflow of the basics of this assessment setup and configuration, how they run, and the data that's available once they do run? I'm gonna guess that, well, we do have more questions. If I can figure out how to make them show up. Okay, we did have a question. Other SIEMs that we support? Yes, we support other SIEMs, QRadar, RSA NetWitness. There you can do custom. So we have organizations that have built their own SIEM, and so we have an SDK where they can build their own integration into that data set as well. So a lot of options there. There's a question around to-do list to remediate a failed detection. So there are remediation reports that help list and provide the IOCs for every scenario that ran. And so we can show examples of that as well. The next stop is the actual scenario library. So this is where we find all the content that we use to run the different scenarios here. So over 2,000 scenarios in the library, different workflows to emulate the adversary or pull some kind of trigger on a workflow that we expect would provoke a response by a security control. This is the card view We also have the list view, where you can see update, the date of the update, the different tags, which is actually how we organize and structure the library itself. So you'll see a lot of MITRE references here, TTP IDs, actually TIDs now, sub-technique IDs as well. We also have the MITRE attack view. So you can look at the library from that perspective. If you're familiar with MITRE attack, the high-level tactics, the techniques, and potential sub-techniques underneath. So you can, yeah, OS credential dumping. So I can pick one and see what kind of options we have here. So being able to drill down, look at the details, look at different content, all of that is available here. You have a filter, so you can search by keyword or freeform text, or you have the filter sets. Probably the most common method of browsing the library are the filter sets. So first and foremost, that alignment with MITRE attack, pick a tactic, be able to drill down on a tactic and explore content that will exercise with that tactic in mind. We also have tags that associate to named ransomware and their TTPs when we talk about their campaigns, or I can focus on security controls. So I'll use DLP as an example. So I will filter this library, and now I'm only looking at content that has some kind of data exfiltration component. So I can just pick one. Let's open up exfiltrate records over DNS A record requests. So I have the description, so I can see exactly how it runs. Once again, access to the source code, but I can also see how I can configure this or change the configuration of this scenario. So organizations that have DLP often have tuned what triggers their DLP. So it could be some kind of trust structured data. So we have an auto generation tool, so you can auto create credit card data, PII data, so on and so forth, or you can create your own based on the triggers that you know to be in your DLP. Go ahead and import that file and use this platform to distribute that data set and have these different agents throughout the environment attempt exfiltration of that data. If you want to encrypt it or compress it, you have those options depending on your capabilities of DLP, or simple compression as well. So a lot of ways to manipulate the data set. But then lastly, how do we want to exfiltrate? In this case, I am exfiltrating over DNS A record resolution requests. I can also pad ping packets or do a simple HTTP post and see if I can get the data out, or do an email attachment. So a lot of ways to exercise the DLP, obviously, but once I have this customized, maybe it's using my own data set, and I've specified the exfiltration method and protocol, then I can do a save as, where now I do have this new copy of this scenario that is pre-configured, created by me, and now I can assign it to an assessment and have the different agents in my environment attempt that method of exfiltration. So there was a question, do we have methods to detect exfiltration? The answer is no. We are not a DLP service. We actually have no security responsibility in the organizations in which we're deployed. So our security responsibility is to test the security tools that are there. We are not protecting, we're validating that your security tools are effective or responding to workflows the way you expect them to. And hopefully that answered that question. Any other questions about the scenario library? Anything you wanted to dig into a little bit deeper? Okay, so we talked about that first workflow, which is security control validation. Let's use this platform to specifically focus on security controls and test them. The second workflow is threat modeling. So a threat-informed defense. Let's identify an adversary and understand how that adversary functions and test ourselves against that campaign or that playbook. So one source of data for kind of understanding the adversary is MITRE, specifically around attack. So you can go to their site, go out to the groups, find groups. You can research by industry. They do a pretty good job of documenting and cross-referencing. In this case, I'm going to be random and pick APT 17. So a China-based threat group that does stuff. Actually, that's kind of a small data set. So let's go with APT 29, which we know is kind of famous as Cozy Bear. We recently had an election, so maybe they're fresh of mind here, top of mind. So I can read what they do, read their techniques and the sub-techniques. But an interesting way of viewing this data is the attack navigator layers. So I can open this up, view this in the navigator view. So once again, this is framework view. You can see the visualization here, the breakout of techniques and sub-techniques with all of the APT 29 documented TTPs highlighted. I can take that and export that as a JSON file. So there it is. I've saved it. And now I can go back into my platform. I'm going to do this here and go to the template library. So template library is pre-built groupings of content. So when you talk about threat modeling, there's a lot of ways to create pre-built assessments that are just designed to run out of the box. So here we have the Drydex FedEx campaign. So you can basically take threat groups and all of their documented TTPs. In this case, we've taken one campaign. So what did this attack look like? What are all the TTPs and components of this campaign? Let's put those together and now make it in a package that's runnable in a customer environment to see if they can exercise themselves and how their security controls would have responded to the different workflows here. So you can see the different contexts here. We have command and control, execution, methods of persistence. So a lot of different workflows that were signatures of this campaign, all put together here in this neat package. I'm about to import another one of these packages. And so I'm going to grab that JSON file that I just downloaded, open it up, and we'll call this APT 29 test. Import the template. I'm sorry, I need to get rid of my other. Apparently somebody else was demoing today. So now let me try this again. It's already there for me. Import the template. And there it is, APT 29, also known as group 0016 in MITRE ATT&CK. So you can open up the details, see all the content as it aligns to TTP IDs from MITRE ATT&CK and our library. So now I can click here, create a brand new assessment that's based off of APT 29. And now I'm in the setup of this new assessment. The content is pre-populated for me, and now I just have to manage assets and run. All right, next stop is getting into more of the Splunk. So I'm gonna come over here and I'm actually gonna demonstrate, it's a beta feature for us, but it is the interesting one for today. So this is the correlation rules. So historically, we've had the integration with Splunk, and so as alerts come in from the different technologies into Splunk, we've been able to map to them and confirm that feed and the health of that feed, and that alerts are making it to your SIEM. We're taking it a step further now by also creating these queries at the correlation rule level. So here I have a simple assessment where I'm running on a system that has CrowdStrike, and I've put one scenario together where I'm running the Lasagna credential harvesting tool. You can see that it has been executed, and so I can go into the summary. It's been run several times, and I can go into one of the results. So as I drill down here, now I have 3 different statuses. First, I have the prevention status. Then I have the detection status, and now I have what is currently called the alerted status, basically mapping to the correlation alert rule. So have all the activity details, mitigation recommendations, detection details, but important here now is alerts. And so with this correlation rule that is designed to parse and fire every 5 minutes, then I can see that I did have a match here where I can, well, I'll show you the rule actually before I do that. Actually, it's not going to do that. Let me go to the detection detail and showcase the raw data. So when we do match, the first step before we hit the correlation rule, we did have an alert. It came from CrowdStrike, so I can pull that information. So we're actually, as we match that data in Splunk, we're pulling it here, so you can see the actual event details that were reported up into Splunk. And as we go down further, we can actually open up the link into Splunk, see the alert, where you can see this device has been found with known malware. There is a specific rule set that I can look at. So the correlation rule itself, I don't have edit access, but you can see what we're searching for, and we're specifically searching for malware or malware attacks in the CrowdStrike feed. So that correlation rule has been established in Splunk. We fired that alert in CrowdStrike. The alert made it into Splunk, and so we confirmed that, and then confirmed that Splunk did fire off the SIEM rule as well. And so customers can create content that triggers and confirms that all of their correlation rules are firing as expected using these different assessments. All right, at this point, any questions or anything we wanted to drill into a little bit deeper? Okay. I am going to make one more stop here, and this stop is going to go into reporting. So there are reporting options. Where I'm going to look is inside the assessment, that security controls baseline report. The first thing I'll look at is the CISO summary report. This is the high level view. And so as it renders, I will go ahead and scroll down through it. First, it starts with the high level summary of what did you create, as in what is this assessment that you put together. So 29 unique scenarios running over 4 assets. Here's your high level numbers, and then your high level results. So as we break this assessment down into the individual test groups, here's how your technology fared, first by prevention, then by detection. Here's your historical results over time, and then here's your pie charts. Because it is a high level report, you have to have pie charts. And then a report card of the different technologies that were exercised as part of this assessment. So the beauty of a live demo is that we are pulling this data from the database, and so it takes a little bit to render, but you can see it's actually all here as it completes the pull. And as I'm about to browse off, then it did complete. So you have options to email the report or download the PDF, and so obviously you can also set this up as an email that is sent each time an assessment is completed. The detailed report is the next step. So the detailed report starts with the same high-level overview of what is this that you put together, some pie charts, but then gets into the actual scenarios. So it goes scenario by scenario with a report card of, actually starts with mitigation recommendations. So understanding what types of tests it was running and where the failures occurred. Basically, it's pointing me at a focus on endpoint protection or antivirus. So there's all of these different scenarios fall into that category. And so if I really do some tuning on my endpoint, then I can knock out 52 findings. And so it will go kind of down that path, understanding how it was testing, what it was testing, and give me some recommendations. Then it gets into the actual scenarios with each report card. What did I do? How did I do? And so eventually I'll get to ones that passed. I will get into my assets. So per asset, here is your report card. And then the actual scenarios themselves. So first one was an exfiltration. That description is pretty scant, but I get my report card and then my mitigation recommendations per agent that ran. The next one, remote service connection. Basically, I'm testing my firewall by establishing an SSH connection over port 443. And so I'm providing results that I was not blocked. I was able to do that, and then some mitigation recommendations. So continuing scenario by scenario, breaking down exactly what we did, how we did it, why it's important, and here's where you should go to make adjustments to improve your environment and your security controls. That is what this detailed view and report does. All right, so 4 minutes left in the scheduled time. Happy to field questions if you have them. So feel free to come off mute. I'm not sure if that actually worked, even though I said you could, and it looks like you can. I can field questions here or the written ones. Right, we have another question. Where are the commands living off the land listed for detections that failed? So different, so there are different ways of getting that. So let me come back here. And they're traditionally in the IOCs. So if I go to, let me find one that is interesting for me. All right, so OTX, let me go to a report. Reports, a remediation report. So today, this is a special kind of report that is assigned to custom templates, but as of tomorrow, then you can actually generate this report from everything. So this is very technical, so have fun with the wall of words, but it starts with the scenario, describes it, but then gets into the details of the run. Where did it run? The specific times. So if you are actually digging into your security controls and trying to find the record of how this ran, then we're giving you more information. So in this case, we are testing security controls specifically against an IOC report that identified IPs or domains that should be prevented. So we have the source port, we have the destination, and we have which system initiated the connection with the specific timestamp. Information that you can take to find that entry in your security technology and hopefully identify either why it was blocked, where it was blocked, or make the adjustment to ensure that it is responded to appropriately the next time. And then TTPs. So, and Todd, welcome. The question actually is around kind of exporting or making the MITRE ATT&CK TTPs part of the exported results. So you'll see a lot of references to MITRE ATT&CK, and as I go into like the APT 29 Dirty Dozen, you'll see views where you can look at the heat map and see the mapping here. But we actually don't do a good job of exposing the actual TTP ID as part of the output. That's being adjusted, and so within a couple weeks, what we will have is on this view, on the summary view, as you are able to export the CSV or even see it here, you'll be able to see the MITRE ATT&CK TTP IDs. So today we go as far as to share tactics, but the TTP IDs will be part of the tags that are exposed here as well. All right, any other questions or anything else you guys want to see? All right, looks like the official time is up. So appreciate everybody joining today. Hopefully I answered your questions. Happy to field questions offline or schedule a one-on-one for a demo and actual Q&A. But thank you very much and hope you have a great rest of your day.